Welcome back to the GT350 Garage. My name is Walter, and this is part 3 of building a high-performance 289 for my Shelby. In this video, we're going to be talking about piston ring end gap, and we're going to talk about a minimum, a maximum spec for the rings. We're going to talk about the way the rings have to be placed on the pistons. There's some specifics that we need to address there. Then we're also going to talk about putting everything together, assembling the rod to the piston and assembling putting the rings on the pistons. So this is going to be an interesting video. Not quite sure how long this one's going to end up yet, but when you get to the end of it, if you like this, give it a thumbs up, and if you found it useful, share it. And if you're not a subscriber, hit that subscribe button. So anyways, with that, let's get into the video. Let's talk about our piston rings. First off, these are our top rings, and you can generally tell a top ring because when you're dealing with, in this case, a plasma moly ring, it's a coated face. Your second ring is going to be a standard cast ring, and that's absolutely fine. Now, on the top of each of these rings, and let me see if I can get this in here close enough that you can see it, there is a dot stamped into the ring, and that dot indicates that the ring has a top and a bottom. So you always want to install the dot up. You got to look closely. Sometimes the dots are really hard to see. Next, let's talk about the tools that we're going to use. You can see that I've got a feeler gauge here that I've disassembled. And these ones that come apart, even if they're made in good old China, doesn't matter. They're close enough that you're never going to have an issue with it. But the ones that come apart are fantastic because you can take the feeler gauges out. And if you can take your feeler gauges out, then you can lay everything out that you're going to use for what you're going to do. All right. Now, these are Hastings rings, and these rings are sold in a plain white box through Summit Racing. I've had good luck with Hastings over the years, and so for this build, I'm using Hastings. Could I use Total Seal? Sure. Could I use Speed Pro? Sure. Could I go with something fancy? Absolutely. I contemplated the possibility of running a zero gap second on this, and I've decided I'm just going to run with what I've got because it's going to be fine. Anyways, on this, you have recommendations that are based off of thousandths per inch of bore diameter. And that has to do with how much the ring is going to grow when it gets close or when it gets hot. Now, what happens with this ring is when it gets hot, it grows and the end comes together and it'll butt. And if it touches, it will lock in the cylinder, preventing the piston from going up and down and doing all kinds of horrific damage to your engine. So we want to make sure that we have enough clearance. In this particular case, this is most definitely not a street engine. This is not a street strip engine. And this is more circle track drag racing territory. As somebody who's more interested in road racing and open track, that kind of thing, I kind of find it obnoxiously annoying that they don't have road racing or circle track racing separated out from drag racing. Anyhow, in this particular case, circle track and drag racing, we're looking at 5 thousandths per inch. So this is a 4-inch bore. That would be 20 thousandths. And then it's 30 over, so we're looking at 20 thousandths and a hair. Okay? And that's literally what it comes down to. So our top gap, we're going to set to 20 thousandths. Now, under the same guidelines, they want you to go on the second ring. Oh, and that's with a forged piston. If it's a hyper-eutectic, you're going to go 7 per inch. They want you to go 55 or 5.5 thousandths rather. So that puts us at 22 on our second ring. And so that's what we're going to do. So we have a 22 thousandths feeler gauge and a 20 thousandths feeler gauge, and those are our final numbers. Everything else here is just strictly for the measurement process. I'm going to transfer this all over to the engine now and show you how I do this at the engine. Okay, so now we're here at the engine. Because this is a floating pin setup, I just stick 2 pins in the piston, and I utilize that as my tool for centering everything up. We're going to start with our chrome top ring, or our plasma moly top ring. We're going to put it in the bore, slide it down in, and then we're going to take our piston and we're going to take it down until it sits on the pins. And that's going to square everything up nicely for us. What we can do is we can rock it just a little bit, and that will make sure that it is square. Pull that out of the way and set it aside. And now we need to start measuring. So we're going to start with a 14 thousandths feeler gauge. So here we go. 14. So if the feeler gauge doesn't fall out, that means it's holding it tightly enough. Let's pull this one out. That's our top ring. Here's our second ring. Put it in. Square it up. $14 falls through. $15 falls through. $16. Pick that up in a second. So 17 on our second ring. So that gives you an idea what our initial gaps are. We've got to take 6 thousandths off the top ring, and we've got to take 5 thousandths off the second ring. This is a pre-gapped set of rings. These are not file fit rings, but we're going to file them anyways because we want the gaps to be correct for the application, not for what the ring set was manufactured at. So if you're buying your rings pre-gapped out of the box, you should still be measuring this. All right, so this is our ring filing tool. And the way this is going to work is we're only going to file one side of the ring. And because I'm right-handed, I'm going to turn the crank with my right hand. I'm going to hold the ring with my left hand. You put the ring against the pins, set it in, and then butt one end against the stone, the grinding wheel. Now, as we turn this, we have to hold it down. And we have to do this so that it basically pulls towards the center of the ring. So I do this pretty gently, and I do it gently on purpose because I'd rather sneak up on it than overshoot it. So again, now here's our second ring. And so I'll go 10 revolutions, and then I keep a file handy, just a little jeweler's file. And all I use this for is just to clean up the edge just to make sure that we don't have any burrs. Okay, so we want clean edges. And so there's our second. Here's our top. You can use the tool. All right, so now we'll take these rings and we'll check them again, because now they've been filed a little bit. All right, so again, in goes the ring. Give the piston a little twist. So let's check. I may have gone too gentle. Now we're at 16. Okay, so that took us from 14 to 17. So our top ring needs to go 10 more light turns. And then here's our second ring. Okay, we were at 17. It's 18, 19, 20, 21, and that put us right on 22, and the feeler gauge stays. So we're going to run that ring. So for cylinder 1, this ring is done. For cylinder 1, this ring needs a little more love. And I'm being extra careful on the top rings to make sure that I ease into it. I used about half again as much pressure on this ring as I did on this ring, and this one went straight to spec. So I'll make sure that I go lighter like I did on this ring on future rings. Okay, just filed it really quick. Let's put this top ring back in. Set the height. We were at 17. All right, I'm going to do this while you're listening. Ring back in. And 20 is a nice snug fit, so this ring's done. Okay, so we're moving to the next cylinder. And I pre-ground this ring a little bit. Let's see where we land. $19, $20, okay. Same thing. All right, we got 22 on our second. And we are a tight 21, so just a hair over 20. And at this point, a thousandth of an inch isn't critical. It's not going to make or break this engine build. All right, so I've already pre-ground cylinder 3. Just make sure it's square. Let's see where we're at. So that's 19. So it needs just the tiniest bit of love. Let's give it that love. Hit it with the file, bring it back. Make sure it's oriented with the dot up. Drop it in. Square it up. That's a perfect 20. So that ring is done. Now we're going to put in our pre-ground second ring. Square it up. Drop my tools. Okay, there's 20 and it's kind of loose. And it's right there at 22. So this one's done. And now cylinder 4. Make it square. Again, I've been pre-grinding these. That one's right on 20. Let's see where this one lands. Start with 20. Right where I wanted it. Loose. 21. Got a little bit of drag, barely. 22. Perfect. Exactly what we want. So that does these 4, and then I'm going to do the other side, and we're going to get to putting rods on pistons. All right, so all my documentation is done. My ring gap's on the top. I was shooting for 20. I got 20 with the exception of one that's probably 20 and a half. And the rest of the rings are good. I have all 8 of the second rings are set at 22. And initially I measured 14 to 15 on the top and 17 to 18 on the bottom. So I document all this, and that's where we go from there. Notice I keep records of everything I do on an engine build. That way I can go back later and I can say, oh, that wasn't right. Or, oh, wow, this really worked well. So I've done this for over 25 years now. I highly recommend keep records. Anyways, moving on. Let's start looking at what we're going to be doing to put this stuff together. All right, Spiro-Locks are probably the most hated part of this job for most engine builders. I know guys that absolutely despise these things. So get yourself a razor blade, cut all the packages open, give them a little rip, and start plucking them out of there. They can tend to be a little stuck in there. but get these things out of the packages. And I'm going to show you how to make these a little bit easier to install. Now, some pistons are made to use double locks. These appear to be single lock pistons, and that's fine. I think double locks are overkill. They're also a giant pain in the butt to install. There we go. All our bags are empty, so trash. All right. 2, 4, 6, 8, 10, 12, 14, 16. Okay, so every piston has a matched set of rings for that cylinder. All the pistons are marked. But the piston rings are either A, going to be in the way, or B, need to be installed first. So let's talk about this. Can you put the piston rings on before you put the pins and spiral locks in? Well, the answer to that is quite simply yes. And the reason for that is because these piston pins do not intersect the oil ring. If this was a 347 stroker, you're going to be in the oil ring, have to use an oil rail support, and at that point, you can't put the rings on until after the pin's in. So technically with these, we can put the rings on first. I'm going to do it both ways and show you that it's not really a big deal. We need to get our pins unwrapped, and then we'll start applying assembly lube and putting these things together. All right, so excuse the funky camera angle, but for our first one, here's our pin, here's our piston, here's our rod. You notice I got gloves on. We're going to use assembly lube, and if you watched my video recently on cam failures, this is that sticky, nasty, drippy stuff that I talk about. It has a purpose. Very limited purpose, but it has a purpose. I'll use this for things like wrist pins. But for anything else, I use Lubriplate 105 for all my bearings. And then if I'm doing a flat tappet cam install, I use a moly paste like Isky Rev Lube. So anyways, getting back on track here. When you grab these Spiro-Locks, you need to get a hold of the two tails and grab them with your fingernails and give them a little tug and spread them out just like so. And this is going to make it so that we can put them in the piston. So actually here, while I'm not using chemicals, I can do this with no gloves. All right, so the first one is always a bit of a challenge. Let me see if I can get this on camera. All right, so we got to slip it in, get it locked into the groove, and then you're just simply going to take your thumbnail and push it in. And when they say it's a spiral lock, as it goes in, it locks into place. Now take your pin, put your pin through, and push it. And you heard that click? That click is how you can be sure that the spiral lock on that side of the piston is fully engaged in the groove. Okay, so I want you guys to be able to see that. All right. I know guys that swear at these things, hate them, and I'm telling you, a little pull on them, just very basic. Give them a little pull. You just want them to just kind of look like this, and it will make your life a whole lot easier when you're doing your install. Okay, so at this point, this is where chemicals are coming out. Keep the chemicals off your hands the best you can. I've been doing this for such a long time, and I've exposed myself to enough chemicals that honestly, the chemical exposure kind of wreaks havoc on my allergies, and it sucks. So if I expose myself to the chemicals too much, then it's no fun. So we're going to put a little bit of lube in the piston. And then we're going to put a little bit in the rod. And now this is where it gets interesting. If you remember the video where we measured everything, the chamfer goes towards the outside of the journal on the rod, and your notches go towards the cam. So this is number one. It's going to be in there like this. That means we now have to figure out which way our piston goes in relationship to it. So we need our valve notches to the top, and that means if my valve notches are on this side, my bearing notches are on this side. And go ahead and spin the pin so that you have lubrication on the entire pin. Now, the second Spiro-Lock is usually the hardest of the two to install. I'm going to show you how I do it, and it's genuinely not that bad. So, get yourself a handy dandy pocket pry bar. This one's from Holly. You can get them from Snap-on, order them off of Amazon, get one off a Snap-on truck, however you want to do it. But just take your screwdriver and work the Spiro-Lock into the bore. It's going to just spiral in. And that's it. Done. Piece of cake. So now we've got a little bit of extra assembly lube on the piston. We're going to wipe that off because we actually don't want that in the rings. We'll wipe it off of the mat on the bench so that it doesn't continue to make a mess. So we basically just want enough lube on there that everything is smooth and lubricated for startup, and now we're good. So now we have a piston, we have rings. We have to start with the oil ring, and you're going to take your expander, and this is a very basic thing I do is the expander always has two tangs, and I put them down. So put them over the ring or over the wrist pin. Grab a couple of oil control rings. I'm going to go to the opposite side, and the way I do these is I like this, spiral it in, and sometimes they don't want to play nice, so you have to back them up. And lock it in. Grab your second oil control ring, and your bottom groove is going to be here. Your top groove here. Top one goes on super easy. Now we're done playing with chemicals. Gloves off. Top ring, so that'll go on second. Make sure we identify which side has the dot. So there's the dot. This is our second ring. And I just simply use my thumbs. Drop the ends into the oil groove and click them into place. And I realize that that's very controversial. Some guys absolutely refuse to do it that way. Other guys don't have any problem with it. Okay, again, identify the top by the dot. And bring it around. Put it in the grooves. And we have a piston assembly ready to go. Now, for the sake of keeping track of things, I've marked the rods, I marked the bottoms of the pistons. I'm going to mark the top. And that way I don't accidentally put the wrong piston in the wrong hole. So there's the process for one piston. Now, I told you can do it with the rings already in. And the reason I like doing it with the rings already in is because the piston's a whole lot easier to work with. So I'm going to set my bottom ring. And yes, I'm putting the ring on backwards for shame. There we go. I'm going to grab the top oil ring. Now my oil rings are on. There's my top. There's my second. Identify the dot. Expand it with my thumbs. Set it in the groove. Turn the piston around. Expand it with my thumbs. Set it in the groove. Done. So now with this one, we're going to put the valve notches facing away. We're going to grab our Spiro-Lock, give it a little tug, open it up. Okay. Get it in the groove. Genuinely, your thumbnail is probably the best way to get this in here. And if it's being stubborn, just grab the tail, lift it up, and give it a twist. Give it a twist with your thumb underneath it. You can also use the screwdriver. The screwdriver makes it go much, much easier. Okay, take our pin. We're good. So, valve relief's away. Let's see if I can do this without getting this all over me. Make sure that the rod notches are away from you. Slide it in. Grab your second lock. Give it a little tug. Pop that tail down in there. Grab your screwdriver and just work it in. They make tools for doing this. Never owned one, never needed one. You can use a pick tool or even a little pocket pry bar to be able to pull everything apart. Now, this rod is marked 2 on one side and 7 on the other side. So clearly, what I need to do, just so that I don't drive myself bonkers, is make that 7 go away. And then mark the top 2. All right, so I'm going to change the camera angle, and I'm going to put this in time lapse. Okay, so just to kind of wrap this up, here's a rod pair. This is 4 and 8. And when you look at these in the block, the valve relief is going to be at the top on both of them. Okay? And with the valve relief on top, you should have the big chamfer out and the big chamfer out and no chamfer really in between. So that puts the notches for your bearings towards the cam, pistons towards the intake valley or the lifter valley, notches towards the cam, valve reliefs towards the lifter valley. And so this pair will ride in the engine adjacent like this on the crankshaft, and this is our pair. So that pretty much wraps it up as far as that. All right, so this basically wraps this video up. Let's cover a couple of topics really quick that need to be recovered. First topic, the ring set I'm using. Again, I told you these came from Summit Racing. They are a white box with a Summit label on them. Inside the box, they're Hastings rings. Hastings makes a nice ring. I have no issue with Hastings rings. I've used them before. Could I have gone with Speed Pro? Yeah, sure. Could I have gone with any other brand? Absolutely. Okay, absolutely. But for our purposes here, there's no benefit. It's not like we're running some really high end, super thin, metric, low tension deal. We're running a standard 16th, 16th, 3/16th low tension with a preset gap ring set. Now, why did I buy pre-gapped rings? Well, it's a time saver and, believe it or not, a money saver. Pre-gapped rings are typically cheaper than file to fit rings, and they take less time to file. So if you're going to get a ring that you're going to put in a 4-inch 030 bore, and the gap is going to be 14, 15 thousandths, right? You want that gap to be 20. So you only have to file 5 or 6 thousandths off that ring. Now, if you buy a file to fit set, they come 5 oversized. So it would have been a 4035. And at that point, you've got to file the living daylights out of them. This is something that when I was building engines regularly 2 decades ago, I stopped buying file fit ring sets. They're a pain in the butt. So don't be afraid to use a pre-gapped ring set with the intention of filing the rings, because you want your gaps to be correct for your engine. You don't care how you get there. Okay? That doesn't matter. As long as you always file them so that when you're running them on the ring filer, or if you have to do it manually with a flat file, always file from the outside in. So you saw the tool I was using. I always turn it counterclockwise. That way it's taking the material inward, not outward. And the reason for that is if there's any facing on there, in these cases they're plasma moly, it doesn't chip the facing at the edge where you're grinding off material or filing off material. So that's that. Now, I know some of you are just chomping at the bits and you're ready to hit the comments. He didn't put the gaps in the right place. Well, guess what? I don't worry about that until I'm ready to put them in the block. So I'll bring the piston and rod assembly over with the rod cap off. I'll set it on top of the deck. I'll have my ring compressor on standby. I'll have my can of WD-40 on standby. I'm going to then line up all my ring gaps right there on the spot. And I'm going to install the piston right then. And the reason I don't worry about it is because if you have to handle the rods and pistons, chances are that stuff's going to get moved around. It's just the nature of the beast. If you move that rod and piston and you just twist it in your hand, sometimes those rings, because there's no oil on them, everything's brand new, it's clean, and everything is moving freely, sometimes they'll move right there on the spot just from moving them. Or you'll brush them and not know that you brushed them, and they move. So your gap placement is not critical until the point of assembly, and we'll be getting to that really soon. So then there's the Spiro-Locks, and I know I'm gonna catch hell over the Spiro-Locks, and I'm gonna have somebody come in and say, you stretched your Spiro-Locks too far. Well, I've been doing this for a long time, a very long time. And I can tell you that I have never had a Spiro-Lock fail because I stretched them the way I did today. And I've installed Spiro-Locks on 18 millimeter pins all the way up to big 990 pins. It doesn't matter what size pin, as long as you have that thing locked in to the groove, you're good. It's not going to come out. Okay. Not the way I showed you how to stretch them, not the way I install them. I have never lost a Spiro-Lock. Now, that is a fun discussion because I have had a connecting rod with a press fit pin lose the press fit, walk the pin into the side of the block, and grind a big giant groove into the side of the block until it found water. So, that's it's just the nature of the beast. And that was not a rod and piston that I assembled. Um, it was clearly a rod that was overheated and had lost its ability to actually create the correct press fit on the pin. So, all things said and done, the next video is going to be installing the crank, setting the thrust, installing the rods and pistons, and getting this short block kind of going. The very first thing I do, believe it or not, is actually install the camshaft. And then once the short block's together and kind of looking like the foundation of an engine, the next thing we're going to do is we'll have a video after the assembly video. We'll have a video specifically on degreeing camshafts and checking piston to valve clearance. And that's going to be a really fun video. I think you guys are going to like it a lot. The way I show you how to do it is going to change kind of the way that most of us learned from the magazines how to check piston to valve clearance. And I'm going to show you not only how to do it, but why I do it the way I do it. And it's more of a professional engine builder way of doing it than it is a hobbyist way. The problem with claying the pistons, like everybody has told you to do for the last 50 years, is it doesn't tell you when you have the smallest piston to valve clearance. Okay. And with what we'll be doing, the way we'll be doing it, not only am I going to be able to show you when we have piston to valve clearance and where we have piston to valve clearance, but also how you can alter that. So the next couple of videos are going to be really cool. I'm looking forward to seeing you guys back watching them. And for now, I thank you for watching, and I'll see you in the next one.